Hello, I'm making this video on principles of microservices. I'm going to explain some of the principles of the microservices mentioned in Martin Fowler and Lewis paper. So microservices is nothing but a way of building software, or we can say it is a application design architectural style uh, uh, architectural style which is used while building any software. So what happen in our microservices? Actually, in microservices, the whole project or whole system is broken down into number of services, which we can call as microservices if it fulfill the some of the 9 principles of the microservices. So in microservices, uh, the system is broken down into number of many small independent services. So each service can run on its own and does just one job. They can talk to each other, and in microservices each service is independent service. That means they can be developed, it can be developed, it can be deployed, it can be scaled, it can be update on it without affecting the other services. So in the before the microservices, there was monolith in picture. So in monolith the developer writes whole system in just a one file. In monolith architecture style, consider this is a system or application, or we can say one project. In monolith architecture style, the whole coding is done inside this one application. So this is a coding. Monolith architecture, the whole coding of the application is written into a one big file. So if any bug occurs, the developer has to find out the where is the bug and fix it, and at the time of deploying, the developer has to redeploy the whole application. So it is somewhat the time consuming, and it is beneficial for monolith architecture is beneficial for the small project, the small project where a complexity is not there. But for complex project or complex system, the monolith architecture is very time consuming and very difficult to um, develop, and very difficult if any bug occurs, it is very difficult to fix that bug. And for the execution, it has to redeploy whole application. So after the monolith, there comes the service oriented architecture in picture. Service oriented architecture. So what happen in service oriented architecture? The drawback of the monolith was somehow minimized in the SOA architecture. What How it is minimized? The big program is divided into number of pieces. this whole a big program is divided into number of pieces, and these pieces is also called as modules, or we can also called as libraries, or it is also called as service. So one big program in SOA is broken down into number of modules, number of libraries, or we can say number of services, but still it is a part of an application. That means where the execution, when its execution comes in picture, it has executed in one process. These whole modules get executed as an application in a one process ID. That means what drawback is overcome from monolith in SOA? In SOA, the if the bug occurs, the developer for a developer it is easy to find out that bug because their code is divided into number of pieces, number of modules, so it is easy for developer to find out that bug and solve the issue. But what about the deployment? Still in SOA, developer has to redeploy the whole system. To make one small change, it has to redeploy the whole system. So SOA solves some of the problems, or some of the problems which occurs in monolith, but still there are problems with SOA also. So this problem or this drawback is solved in microservices architecture. So what is how the microservice overcomes that drawbacks? That in microservices the system is divided into, or system is broken down into number of services, and we can say number of independent services, small services, where where each service is an independent application. Each service is an independent application. Each service is an independent application which run on its own process in its own memory, occupied its own resources, occupies its own resources, and it's developed, deployed independently. That means in microservice is also a way of building software. So instead of making a one big program as in monolith, in microservices we break down into many small independent services. So what is the meaning of independent services? That means each service in microservices, each service is an independent application which run on its own process. It has its own memory, it occupies its own resources, and each microservice is developed, deployed, even updates, even scaled independently without affecting the other microservices. These microservices can communicate with each other also. So this is microservice 1, 2, 3, 4, 5. So they can be deployed separately. So updating one service, for example, if any bug occurs in this M1 service, if any bug occurs in this M1 service, developer has to only look after this M1 microservice. The developer does not need to touch these other services. He has to solve that bug into this service and redeploy this service only, the M1 service, without affecting the other microservices. So this is the main power of microservices. The Martin follower uh, and the Lewis published a paper about the 9 main principles of the microservices. How this service defines as a microservice. So this is published by Martin Fowler and Lewis. So we see the principles of microservices. So first principle is componentization. Componentization via services. So what is componentization via services? There was a componentization in SOA also, but in SOA the componentization was via libraries. This is SOA. In SOA there was a componentization, but it was via libraries. Means what? Means componentization means making components. So in the SOA, as we see, the one big program is divided into number of services, libraries, or we can say modules. But these are these libraries, we can say libraries or modules, they are not independent modules. They are just divided into that program. They are not independent. They still run as an application, a single application. So in componentization via libraries, we break the system into number of libraries, and but they still run inside one single process. Means it has only one process to run on it. If if this one part, if consider if this one library or one part consider if this one part crashes or needs an update, the developer needs to redeploy this whole application to fix the problem of any library. So it is very time consuming and less flexible as compared to the componentization via services. So what happens in componentization via services? So in componentization via services, the big program is divided into number of services. A big pro here also componentization via services. The system is broken down into number of microservices, but these microservices are independent services. Independent services means, okay, consider this is M1, this is M2 microservice, this is M3, this is M4 microservice, this is M5, and this is M6 microservice. So in the componentization via services, that means the first principle of microservices says that each component or each service should be independent service. Each service should be independent service. Means the big program is divided into small independent services, so they can communicate with each other. And each service does a specific business task. Means the first principle of microservices says that each service, each microservice should be designed for the accomplishing a specific business task or specific business function, and these services should be separate programs. That means this micro M1 is the separate application, M2 is the separate application, and somehow they can communicate with each other. So because they are separate, each service can be developed, can be deployed, and even update and scaled separately while touching the other microservices. For example, there is a bug occur in M1 microservice. Then the developer does not have to fix that bug from M1 and redeploy whole the application. No, the developer has to fix that bug inside M1 without touching this M2, M3, M4, M5, M6. The developer needs to fix the bug in this M1 microservice and redeploy only and has to redeploy only M1 microservice. So this is the componentization via services. So this makes the system very reliable, very flexible, and easy for maintenance. So this is, for example, we consider one example that uh, in okay, imagine there is one big kitchen and where cooking everything, pizza, burger, and coffee, we can say. Even if, see, this is a one big kitchen. Consider, imagine this is a one big kitchen where cooking everything. we are cooking everything. For example, this is pizza, then coffee, and burger. Okay, even if we divide the work into pizza team, coffee team, burger team, but they are still stuck into the same kitchen. And if this kitchen fails, and if this kitchen fails or kitchen closes, nothing will work. Yes, so instead of that, consider a big food court. Okay, consider a food court where each stall is separate. So here is stall for burger, here is a stall for pizza, and here is a stall for coffee. Okay, this is a food court. Each stall is separate. Pizza stall is separate, burger stall is separate, coffee stall is separate with its own kitchens. Okay, so if the pizza stall closes, the others will still work. The others still work. We can also upgrade this coffee stall without affecting the burger and pizza stall. So this is the componentization via services, and this concept is an example of componentization via libraries. So in short, in microservices, the big program is divided into number of services, number of components, which are services, independent services, separate services, which we can develop or deploy, update or scale independently without affecting the other services. So this is the concept of componentization via services. Then the second principle is organized around business capabilities. Organized around business capabilities. So this is the second principle of microservices. So what it says that each microservice is designed to handle some specified each microservice should be designed for a specific business logic, or we can say business task, or we can say business function. Yes, what is the second principle says that each microservice should be designed to handle a specific business logic or specific business task. So for example, in our application we are creating three microservice. One is for validation, one is for processing, and one is for integration. Yes, so So each microservice should be designed to handle some specific function, some specific design business function. So instead of splitting based on the technology, like front end team, back end team, the system should be splitted based on the business capabilities. So all the related features of that business area are grouped inside this one microservice. That means the team the team that owns this microservice also owns the full business capabilities or functionalities, end to end functionalities. It's not about the size, actually it's about the purpose. Microservice is not defined by how small it is, but it is defined by how focused it is. So the main goal of the microservice is that each microservice should be manageable by a small team, and each microservice should handle a specific business logic. So this is the main purpose of this second uh, principle. So the second principle says that each microservice should be designed to handle some specific logic or specific task, business task. Don't split the system, don't split the team into based on the technology, that is front end team, back end team, UI team. No, split the system based on the business capabilities, and the size should be the size team size for one microservice should be two pizza team. Two pizza team means uh, two pizza team means a team small enough to feed with two pizzas. So services can be vary in size, but as long as they serve one clear business capability, they are still considered as a microservices. So this is the second principle of microservices, that is nothing but organized around business capabilities. Then the third principle is the third principle of the microservices, smart endpoints and dump pipes. So uh, third principle is smart endpoints and dump pipes. So what is the meaning of it? So before that, first I'll explain what was there in SOA. So this is service oriented architecture. So in service oriented architecture, as we know, the big program is divided into a number of modules. Okay. So how they communicate with each other? For example, consider This is library 1 or module 1, and this is library 2 or module 2. If the L1 wants to communicate with the L2, so how it communicates? So there is an ESB, enterprise service bus. There is ESB concept through which the L1 can communicate with this L2. So in SOA architecture, the enterprise service bus uh, contains some business logic also, and it has the business the ESB contains the business logic, and or we can say in SOA architecture, a lot of logic was put inside this enterprise service bus. ESB is nothing but a middleware pipes for making for making possible the L1 and L2 communication. So this makes, as the ESB as the lot of logic was put inside the ESB, the complexity of the ESB was more in SOA. So if the this middleware gets failure or faces some problems, the communication was impossible in the case of SOA. It was heavy in SOA architecture. So in microservices, what the third principle of the microservices says that the communication from, consider this is a microservice 1 and this is the microservice 2. So in microservices, if M1 wants to communicate with M2, the communication should be as simple as possible, just passing the text messages. So the communication happens uh, in microservices REST over HTTP. Obviously there are types of communication, but the third principle of microservices says that each microservice should have the should design to have the functional or business capabilities end to end. That means this M1 should be designed, should be coded so that M1 is responsible to process the function, process the end to end function, and the communication should be the simple. So this so the Dump pipes is said in microservices, that in microservices communication is minimal and straightforward, and services should be self contained, easy to test and flexible. So it is said that smart endpoints and dumb pipes, the communication, that means this pipe should be dumb. So there are uh, methods of communication, there are types of communication, there types of communication. So first is the synchronous type, synchronous communication, and asynchronous communication. So what is synchronous and what is asynchronous communication? This is first sync, and this is async. So what is synchronous communication? Consider this is M1 service and this is M2 service. This is M1 and this is M2 service. So M1 wants to communicate with this M2. So in synchronous communication, okay, we got M1 got the request and M1 has to communicate with the M2 to fulfill that request. So M1 sends request to the M2. M2 receives that request and process that request and gives the response to M1. After receiving the response, the M1 should continue with its further execution. That means in synchronous communication, M1 sends request to the M2 and waits until the response from the M2 comes. Once the response from the M2 comes, the communication get further processed. So this is the synchronous communication. So it happens over rest over HTTP. Rest over HTTP. And what is asynchronous communication? So this is M1 and consider this is M2. This is M1, this is M2. So M1 wants to communicate with the M2. Okay, M1 gets request and M1 has to communicate with the M2. So M1 sends request to M2 and M1 doesn't wait for the response from M2. Immediately he started its further execution. And when M2 gets available, M2 should be up and running to fulfill that request. So when M2 is available to fulfill this request, M2 processes that request and sends the response to that M1. And the further execution based on that response should then processed or executed by this M1. This is asynchronous communication. So for this asynchronous communication, there is a message broker. There is message brokers are available. So what is the work of message broker is, so I'll explain it with another diagram. So this is M1, this is M2, and this is a message broker. The message broker is nothing but we can achieve the message broker using ActiveMQ, RabbitMQ, Kafka. So this is a message broker. So when the M1 wants to send a request to M2, the M1 has to send request in this message queue, in this message broker, and it further executes. It starts the execution with its further processing. So if M1 wants to communicate with M2, if then M1 sends request to this message broker. So message broker is achieved by ActiveMQ, or we can say RabbitMQ, or there is a Kafka to achieve this queues, message queue, or we can say message broker. So when this message broker sees when this M2 is available to receive the request, and when the MQ is available to receive the request, that request is sent to the MQ by message queue, and this M2 processes it and sends response back to, not directly to the M1. It gives response to this message queue, and further it gives response to this M1. So this is the asynchronous communication. So this is the second principle. The third principle says that there should be smart endpoints. That means each microservice should be capable for executing end-to-end functionalities, end-to-end capabilities, and the communication should be as simple as dumb, so that it is called as dumb pipes. So there are types of communication. So synchronous communication, in synchronous communication, one service calls another service and waits for its response, and once the response occurs, means only after receiving the response it can further process with the execution. So in the Spring Boot, typically the synchronous communication happens with the web client or a REST template, and in asynchronous communication, services or service don't want to wait for immediate response. Rather it sends request to the message queues or message brokers like RabbitMQ, ActiveMQ, or Kafka, and when that microservice gets available, the message queue sends request to that microservice, and microservice process it and gives response to message queues. And when caller microservice gets available, it sends reply to that microservice. So this is the asynchronous communication. So what is the advantage of smart endpoint and dumb pipes is that language independence. That means each microservice, see, all the logic, all the coding for the business logic inside is inside that microservice only, and communication should be dumb. That means it gives the advantage of language independence. It gives the advantage of language independence. What it means? That means M1 can be designed in another coding language. For example, consider it is designed in Spring Boot, or we can say it designed in Java. M2 can be designed in another language, Golang. Yes, it brings the language independence concept in picture. As the third principle of the microservice says that smart endpoint, that means each microprocessor should be responsible or should be coded in such a type that it can perform end-to-end functionalities. All the logic should be coded inside that microservice only, and the communication between between the microservices should be as dumb as possible, so that each microprocess can be written in any language, the condition is that language should support the REST standards. So this is for example, consider, we can say we can take an example of Facebook. Okay, each person, that is nothing but a microservice. Each person has their own account, or we can say has their own knowledge. That means each microservice has their smart endpoint, and the messages sent, we can send messages on FB also, na? The messages sent are very simple text. That means that is nothing but the concept of dumb pipes. The best example for this is WhatsApp groups. So each person is nothing but a microservice. Each person has their own knowledge. That means smart endpoint. Each person has their own contacts. Each person has their own messages, own settings, own privacy settings, etc. So this is nothing but each microservice, it is a concept of smart endpoint, and the messages sent are very simple. So it is a concept of dumb pipes. So we don't need a super complex system to deliver the WhatsApp message. We just need a simple medium to send a message. So in microservices, the synchronous communication happens REST over HTTP, and asynchronous communication happens through the message queues like ActiveMQ, RabbitMQ, and Kafka. So let's move towards the fourth principle of microservice, that is nothing but design for failure. Okay. The fourth principle is design for failure. So what is design for failure? So microservices tells us that you should design each microservice so that it can handle the failure situations also. See, in microservices, any service can fail at any time. This is the surely possible situation. So the system must be capable or must be designed to handle such types of failures. So this is the concept of design for failure. So instead of assuming everything will work fine, microservice should consider failure. Failures are normal. That means while coding a microservice, the developer should design that microservice such as that it can handle the failure situations also. For example, failure situation means what? This is microservice 1, this is microservice 2. Okay, microservice 1 and this is microservice 2. Consider this is a situation of synchronous communication. M1 sends the request to the M2 microservice, but there is some problem with MQ. Problem means we can say it is loaded with other request. It is M2 is busy in fulfilling other request. So M1 sends the request to the M2. As it is a synchronous communication, M1 waits until the M2 responds and it further processes the execution only after receiving the response from the M2. So in this situation, if M2 is somehow it is not able to fulfill that request, so M1 unnecessarily giving the resources to the M2 and keep busy our resources into that procedure. So this fourth principle says that the M1 should be, or each microservice should be designed to handle such type of failures. So how to achieve this? So in this principle, there are fault tolerance mechanisms are there. So first is the circuit breaker. So what is circuit breaker? So consider, okay, so concept of circuit breaker. So this is M1 microservice, this is M2 microservice. I'm giving this name M1 and this is M2 microservice. Actually circuit breaker, what it says that, okay, M1 sends request to M2 and M2 somehow M2 is facing some problem, so it is unable to send a response. Then M1 sends another request to M2. M1 sends another request to M2. So this is sending request to M2, but M2 is busy. M2 is unable to process the request. So the circuit breaker mechanism is like a safety switch. If a service keeps failing 2-3 times, the circuit breaker stops further calling. The circuit breaker stops further calling to that microservice. See, M1 first sends request 1 to M2. It is unresponsed. So it sends request M2, it is unresponsed. It sends third request to M2, still it is not responding. So M1 should be designed in such a way that it takes it as a failure, that responses are not coming for 2 to 3 requests. That means it is a failure, and consider at M1 that it is a failure, and M1 should be handled that failure smartly. So in circuit breaker, M1 circuit breaker sees request 1 is unfulfilled, request 2 is also unresponse, request 3 is unresponse. So at the fourth request, it declares it as a failure and it breaks the circuit. That means it stop calling to the M2 for some time. It stops calling to M2. Again after some time, it again raises request to M2. Waits for its response. Response is not coming. Sends request to request. Response is not coming. Request 3, still response is not coming. At the request 4, it again declares as a failure and stops calling to M2 for some time. So this is the circuit breaker fault tolerance mechanism in microservices. What happens by this? See, M1 unnecessarily busy their resources to sending request to M2, and increases the burden of the M2 also. So M1 and M2 both are in drawbacks now. So rather than after few many requests, the M2 gets hanged and M1 also finished his resources. So instead of that, circuit breaker stops calling to M2, releases the resources of M1 and decreases the burden from M2, so that the microservices M1 M2 does not get hang up, does not get crashed. So again after some time, M1 raises the request for M2. If the response is coming, that means yes, it is success. But if response is not coming, it considered it as a failure and sends to the client that alert the client that wait for some time. Yes, the server or we can say the service is busy, so wait for some time. So this is the circuit breaker concept in design for failure. So it is implemented in Spring Boot by using the POM dependency resilience 4G. Resilience 4G. So to implement the circuit breaker concept, we have to add the POM dependency resilience 4G, so that we can achieve this, we can implement this circuit breaker into our application. Then next fault tolerance mechanism is timeout. What is timeout? So in the timeout, if a service takes too long to respond, don't wait forever, fail fast. So this is as same as the circuit breaker, but somehow it is different. So this is M1, this is M2. M1 is calling to M2, but M1 is not getting any response from M2. So it waits for some time, and after that time lapses, it declares it as a failure. So what happens if this M2 is running slowly? So because of this slow service could block the whole request chain. As we know, the system is a system is broken down into number of microservices. That means there is obviously the request chain is there. Yes, this microservice sends request to this service, this microservice sends request to this service, this microservice further sends request to this service. So the whole application is made up of this chaining microservices. So consider this microservice is not responding. This microservice has some problem, or meet some failures, so that it could not further move. So because of this slow service, it could block the whole request chain of the system. So the timeout mechanism says that wait for some specific time, and within that time is response is not coming, declare is at a failure. Don't wait forever, it fail faster. So in the Spring Boot, time out is handled with the web client and REST template mechanisms configurations. And then the third fault tolerance mechanism is bulkheads. So what is bulkhead? So in microservices, in bulkhead is actually separating or isolating resources or isolating threads. So failure in one service does not consume all the system resources. See, bulkheads means what? If M1 is, see in this example, consider M1 is calling to M2. Okay, somehow M2 is not able to process that request. So what, it waits for some time, m1 waits for some time and isolate the resources, because for requesting m1 keeps busy his somewhat resources to give somewhat resources to that request. So if it gets continuing of raising another request, it is unnecessarily busy its resources. So there is another mechanism called bulkheads, which isolates the resources, isolates the threads, isolates the connections. So failure in one service does not consume all the system resources. So this is also implemented in Spring Boot by using the Resilience 4J uh, package, POM dependency. So these are the fault tolerance mechanisms to handle the failures in microservices. There are also another mechanisms, monitoring and real time monitoring. We can also say as real time monitoring. What is real time monitoring? So see, in monolithic architecture there is only one log of one program. Yes, in monolithic architecture log should be maintained in process, so that it considered the responses. Okay, then in SOA there is also the logs are inside one uh, in inside one place. But in the microservices concept, in microservices, so this is one service, this is another service, this is another service, this is another service, this is another service. So each service has its own database and has its own logs. Yes, because it has own database. Oh, sorry. See, as the request comes to this first microservice, it generates some logs and saved it inside this log, saved in inside this log. Yes, and then this service sets saves these logs inside this service inside this. So the logs are also distributed in the microservices concept. So the how it is identified that this logs is belongs to this request? So for that there should be a real time monitoring. There should be a real time monitoring. For this elk is used. elk is used Elasticsearch, Logstash and Kibana. So these logs should be centralized. These logs should be centralized into one place, so that the developer can get that response at one place, get that logs at one place. So this is nothing but a kibana. This is nothing but a kibana. So there is a mechanism to maintain that logs, and each, okay, this has a trace ID also. That means, for example, consider the trace ID of this request is 123. So this is the log generated for 123. This is also the log generated for 123. So this is the trace ID, so that the developer can understand the response of one trace ID. So this is nothing but the real-time monitoring concept and distributed logging concept. This is distributed logging. So uh, real time monitoring means there is some way to monitor the metrics, that means the CPU, memory, custom business metrics, so that if the scaling is needed, if the problem is coming inside the metrics, then we can expand or we can scale that system. So that the metrics is important in the microservices. And there are also the ways for health monitoring, service health monitoring. So actuator and metrics are used inside this real time monitoring, and this is the concept of distributed logging and tracing. So add a unique ID to each request, so that so each service logs with that ID, and so that you can track, or we can track, or developer can track the request across the multiple services. So in the Spring Cloud Sleuth is used for which automatically adds this trace ID and span ID to logs. Then micrometer is used to send the metrics, that health metrics, the system metrics, and sleuth. Sleuth is used for automatic this adding trace ID and span ID, and ELK stack is used. So in Spring Boot, how it is implemented? So sleuth is there. Spring Cloud Sleuth, it is also Spring Cloud Sleuth, which automatically generates the trace ID and span ID. And for monitoring the metrics, there is a micrometer, and for this distributed log, there is a ELK, elastic search log stash and kibana. So these are the four principles of the microservices. There are total 9 principles available available inside the Martin Fowler paper. So I explained this first 4 principles of microservices in this video. So the first was the componentization via services, so that what it says, I am summarize it. The componentization via services means can each service should be independent. Each service should be independently developed, deployed, independently updated, and independently scaled whenever they want to. And so each microservice should be independent. Means the big program should broken down into the whole system broken down into number of independent services. This is nothing but the componentization via services. The second principle is organized around business capabilities. So what it says, the each microservice should be designed or should be designed for a specific business task. For example, payment, for example, order, for example, customer profile. So each service should be designed to handle a specific business function. And it is manageable by a small team. Means instead of splitting the system based on the technology, it should be split by business capabilities. Means don't split the system, don't split the team as this is UI team, backend team, DevOps team. No, rather split the teams based on the business functionality. That means this is consider this is a microservice for payment validation function. So for the payment validation, UI is required, backend is required. So the team of the microservice, the team of each microservice should responsible for that microservice. So rather than splitting based on the technology, it should split on the business capability. And the team should be as small as 2 pizza team. Then the third principle is smart endpoints and dump pipes. Smart endpoint is nothing but a microservice. The microservice should be capable of handling end-to-end functionalities, and the communication should be as dumb as possible. So we see the example of WhatsApp, that each user, that's nothing but a microservice. Each user has their own knowledge. That means each smart endpoint, it has its smart endpoint. And the communication, it doesn't need any complex system. It just need the medium to pass the text. So this is the concept of smart endpoints and dumb pipes. So it brings the language independence feature into the picture, that every microservice can be designed as per the team's expertise. If that team is expert in Java, they can build by using Java. If the team is expert in .NET, they can build that microservice using .NET. So this is language independence advantage comes into the picture because of the smart endpoints and dumb pipes. Then we saw the communication types, synchronous and asynchronous communication. In Spring Boot, the synchronous communication is happened in REST over HTTP, and in for asynchronous communication there is message queues available, like ActiveMQ, RabbitMQ, Kafka. We can also say that message broker. So through that message broker or message queues, the communication happens. Then the fourth principle is design for failure. It says that in addition to the success, in addition to the coding for success, each microservice should also capable of handling the failures. That means each microprocessor should be coded in such a manner that it can handle the failure also. So for this design for failure, there are fault tolerance mechanisms are there, then monitoring mechanisms are there, real time monitoring, and logging, tracing, distributed logging is also available. So in fault tolerance mechanism, we can use circuit breaker, timeout, or bulkheads uh, mechanisms by adding the resilience 4J POM dependency. And in real time monitoring, we can actuator and metrics, we can trace the metrics of the system or the health. We can monitor the health of the service, so that we can say the failure is near to come into this microservice. So if that failure uh, is because of the system metrics, so we can scale it before time, so that failure uh, get failure does not come in the uh, will not come in the future. So this is real time monitoring. So in the Spring Boot, the sleuth is used, Spring Cloud Sleuth is used to use for health monitoring purpose. Metrics is no sleuth is used for uh, okay, sleuth is used for automatically adding the trace ID and span ID for the logs. Then micrometer is used for send the metrics, the system metrics and the service health metrics. And ELK is used, that Elasticsearch, Logstash and Kibana is used for this distributed logging concept. Okay, thank you.